Hi, Algebra 1. We're going to be working with lesson 15 here in Unit 5, and we're going to be looking at functions involving percent change. So continuing on the idea of things changing by a percentage. In this first problem, you're looking at a book that was originally $32, and then it was 25% off, and Priya is going to use another 25% off with a coupon. And your job is to figure out, if there's no sales tax, how much did Priya pay for the book? One common misconception here is that people will see that we're taking 25% off once and then again and think that that's 50% off. This is not 50% off, and here's why. If you're looking at 25% off of $32, well, 25% of 32 is $8, so it's $8 off. 32 minus 8 is 24. Then we're going to take 25% off of that, and you're going to end up with 25% of 24 is 6. So you're going to take that extra $6 off. You're going to end up with a total value or total price of $18. And this is not 50% off. 50% of $32 would have been $16, and it's not $16, it is $18. After 1 year, we're going to add on 18%. So we're going to take that original 450 times 1.18, and that's how we increase it by 18%. That's what we did in lesson 14. And you're going to end up with a total of $531. For 2 years, we can take how much she owed after 1 year, which was $531, multiply that by 1.18 again, another 18% increase. You're going to end up with $626.58. And then we go over here. I noticed I made a mistake right there. And then we go for our 3rd year, take that value at the end of 2 years, multiply that by 1.18, another increase of 18%, and you end up with $739.36. We are going to skip number 3 here and go directly to number 4. For number 4, we can use the a times b to the x formula for exponential growth that we've been working on. A was the original amount, which was 450. And you notice back in number 2, all we did was we kept multiplying by 1.18 over and over and over again. And so we're going to multiply by 1.18 x number of times. X is going to be the number of years. And this would give us the total amount that she's going to owe. In this problem, we have 3 people who have taken out loans of $1,000. That's what we're starting with. Go ahead and circle that. But they each have different interest rates. So we're going to start by doing loan A here together. If it's a 12% interest rate, after 1 year without paying anything on that, you would now owe $1,000 times 1.12 with that increase of 12%. After 2 years, you would have started with that $1,000, and now we have to multiply by 1.12 2 times, because now you'll owe that for 2 different years. After 3 years, we would multiply that $1,000 times 1.12 3 times. So we can simplify this. For 10 years, we would take our $1,000 and we're going to multiply it by 1.12 10 times. So now I can use an exponent. And in the last line, we're going to simplify this into an equation. So now my exponent is going to be x, representing how many years we've gone without making any payments. Here's the completed table. I did use exponents in these instead of writing out every time we're multiplying, just to save some room. But down here at the bottom, you can see our final equations. That 24 or 0.24 right here, that's where we get the 24%. And the 0.306, that's the 30.6%. And remember, it has to be greater than 1 in order to make these increase. Here I've graphed those 3, and this is the 12% line, the blue line is the 24% line, and the red line is the 30.6% line. So you can see that they're all starting at $1,000, but they're changing differently. And your book asks you the last question, based on your graphs, how many years would it take for each account to double? So from 1,000 to 2,000. So the red line, which was, well, we'll start with the purple. The purple line was our 12% line. That's going to take us just over 6 years. The blue line, or the 24% line, is going to take us just over 3 years. And the red line is going to take us about 2.5 years, maybe just a little bit over, to double.